Okay, hello everybody. Gonna go to my files, get some Algebra 2, so I know we're into new things here. Trig. Uh-oh, this is not the files that I wanted. I wanted to go into my iPad Algebra 2. Algebra 2 is what I want. There we go. Algebra 2. I'm gonna do some problems with you guys. Y1, three of those up to the 80 smart score level, and then Y3 and Y4. Just some problems to do with you guys. All right, here we go. Soccer player is going to kick a soccer ball from one corner of a field to the opposite corner. If the field is 80 yards long and 60 yards wide, how far will the soccer player have to kick the ball? So this guy is going from here all the way to here, and he's kicking the ball that way. It says it's 80 yards long and 60 yards wide. How far will you have to kick it? So that's just classic Pythagorean theorem. 60 squared plus 80 squared is equal to x squared. And I'm just using my calculator here. So on my calculator, I would go ahead and add 60 squared plus 80 squared, and then I would square root that answer. So 60 squared, again, I'm just using my phone as my calculator, plus 80 squared, and right now it's also sideways. 60 squared plus 80 squared, then I'm going to square root that answer on the calculator, and you should get 100. Yay, 100 is my answer. Woohoo! All right, there's the first one. That's Y1, smart score of the beginning. So smart score 43 now. Again, Y1. Sean is fishing from a small boat. His fishing hook is 6 meters below him. All right, so he's in a boat right here. Here he is. I'm in a boat. I'm in a boat. I love that song. His fishing hook is 6 meters below him, and a fish is swimming at the same depth as the hook 3 meters away. So it's like, here's his fishing line. All right, hook 6 meters below him. That's 6. And a fish is at the same depth, just 3 meters away. Hello. I'm a fish over here. How far away is Sean from the fish? So that's going to be that guy right there. Boom. There's our x right there. So again, same thing. 3 squared plus 6 squared is equal to x squared. So I'm just going to, again, use my calculator on there. Obviously, I get 9 and 36. That's equal to x squared. And then, add those two things together there. 36 plus 9 is 45, and that's equal to x squared. And square root 45 to get x. That, and it says, if necessary, round to the nearest tenth. So on my calculator, I would just do square root 45, and it says 6.708. So I would do 6.7 on my thing here. 6.7 meters. 6.7. Done. Beautiful. Let's see. Another one for Y1. All right. Smart score of 83 now. 83. Okay. So we're getting up there. Again, all I want you to do is get above an 80. What's the length of the hypotenuse? Wow. This is a smart score of 83. Oh, yay. Okay. So, interesting. Round to the nearest tenth. 2 squared. Okay. Plus 1 squared is equal to c squared. Is this seriously all we have to do? All right, this is weird. So obviously this is going to be 5. 2 squared is 4 plus 1. So 5 equals c squared. Square root that, and you get c. So my calculator is going to root 5. Should be like 2 point something. Square root 5. Yeah, round to the nearest tenth. So 2.236. I'm going to go 2.2. 2.2 would be my answer there. All right, so please, hopefully, do good on this section. Everybody should get 100 on Y1 and get that half point extra credit. You might not think that's a lot, but in the realm of things, it's actually 20% extra credit. It's a lot. It's huge. All right, so I'm just going to clear all that stuff out. Very good job. So Y1 is done. Here we go. Y3, SOHCAHTOA, trigonometry. So I say SOHCAHTOA because everything that has to do with trig lies within SOHCAHTOA. And just to kind of emphasize that, this part right here, that says the sine of the angle, and I'm going to say theta for the angle, is equal to the opposite of the angle over hypotenuse. Okay, the cosine of any angle, so the cosine of theta, is equal to the adjacent over hypotenuse. And then last but not least, I'll do that one in black, I guess. The tangent of any angle, angles, that's theta, is equal to the opposite over the adjacent. So that's SOHCAHTOA for you, all right? And it says find the sine of E. Find the sine of angle E. So they're giving you theta. So E is theta right there. That's the Greek letter for T, or theta, angle. So that's the angle, and it wants the sine. So we're looking at this thing right here. So katoa. So is opposite over hypotenuse. So opposite, that would be opposite that. That's the opposite side. So 56 would be opposite. And then hypotenuse is always opposite the 90-degree angle. So 65. 56 over 65 would be your answer. Simplify your answer and write it as a proper fraction, improper fraction, or whole number. Could that be reduced? Let's see here. 65 divided by 5. I'm just working out in my head, just out loud. 56 divided by 13, maybe? No. Okay, so it can't be reduced. So that would be your answer there. Opposite is 56. Hypotenuse is 65. Opposite over hypotenuse. So the sine is 56 over 65. Boom. There you go. So there's your first trig question. Nice and easy. I mean, well, I don't know if you think it is, but it's pretty easy. Anyway, SOHCAHTOA. That's where it all begins. All right, let's see what the next smart score is. Smart score of 19. So I'm not really jumping too high here. I'm going step by step. The sine of x. So we know that the sine function, let me get that out of the way. The sine function is the SOHCAHTOA, right? Toa. It says the sine of x. So here's x. They're giving you theta. So the sine of x is equal to opposite over hypotenuse. Let me change my color here. Opposite of x is 8. The hypotenuse is 10. Hypotenuse is 10. How do you know that's the hypotenuse? Because it's always going to be across from the 90-degree angle. That is always going to be your hypotenuse. Always across from the 90-degree angle. So 10. Obviously, that one reduces, so we can divide both of those by 2. We get 4/5. So the sine of x is 4/5. Cool. Let's see what our next smart score is. Go. 49. Okay. The sine of f. All right, so here's f down here. The opposite is 24. Again, it's SOHCAHTOA. So I'm not going to write this every single time, so hopefully you get used to it. So the sine of f is equal to, let me change my color here, opposite over hypotenuse, 26. You might be thinking, hey, where'd 26 come from? That's the hypotenuse. It's across from the 90-degree angle. Hypotenuse. It's always across from the 90-degree angle. 24 over 26, again, that reduces. I can divide that by 2. So 12 and 13. So 12 thirteenths would be my answer there. Beautiful. All right, what's next here? Smart score of 49 up to a 55. All right, so we're going pretty good here. R. All right, the tangent. So that's the TOA. SOHCAHTOA. The tangent of R is equal to opposite over adjacent. In this case, here's R, which means 12 is opposite. And the adjacent side, guys, take a look. What's the problem? I don't know what it is. I have to figure that out. Oh no, I have to figure this out. How are we going to figure that out? Oh yeah, Pythagorean theorem. That's what we just did in section Y1. So, Pythagorean theorem is x squared. X, that's an x right there. Oh my gosh, I keep messing up. X squared plus 12 squared is equal to 13 squared. X squared plus 144 is equal to 169. Subtract that, you get 25. So x squared equals 25. And then square root that answer, you get x equals 5. All right, so there you go. So the adjacent is 5. So you get 12 over 5. That is your final answer, 12 over 5. Actually, let me do that one again. I'm just going to do that in a different color. Final answer, 12 over 5. Submit. All right, not bad, not bad. There we go. Smart score of 75. Ooh, jumping ahead. What's that? Check mark over the 3. Oh, it's a radical symbol. Yes, we do know radicals. It's okay. Don't worry. You're going to be right. Tangent. So it's TOA again, right? Tangent is TOA. Tangent of, what is it? S. Tangent of S is equal to opposite over adjacent. The opposite of S, here's S. The opposite is 30 root 3. Okay, no worries. Over the adjacent of 30. Wow, that's awesome. Look at that. They cancel out. So you just get root 3. Nice and easy one. And it does say, write your answer in simplified, rationalized form. So that means no decimals. Do not round. No decimals. Leave it as radical 3. Leave it as root 3. You must do that or else you will get it wrong. Okay? All right. Smart score. Let's see if we get above 80. Yay, 81. All right. So this is as far as I really want you to go. If you want to go further and get 100, get that bonus points, please do. All right, cosine. So, see how I'm writing it every single time? TOA. Cosine is adjacent over hypotenuse. So here's I. Adjacent would be the one right next to it, adjacent. And hypotenuse is just going to be 7. All right, because it's across the 90, so that's the adjacent right there. So the cosine of I is equal to adjacent over hypotenuse. What? Write your answer in simplified rational form. Okay, 4/7 is done. 4/7. Boom. That was an easy one. All right. Next one, smart score of 89. Crushing it. Find the tangent of t. That's the TOA. TOA. Oops. What's going on here? TOA. So the tangent of t. There's the angle right there. Opposite is the O, so root 17. Root 17. Over adjacent to root 13. Aha. So now, rationalized form. Rationalized form, what it says here, means you cannot have a radical in the bottom. It must be rationalized. So in order to do that, we have to multiply both the top and bottom by root 13. Multiply that by root 13, multiply that by root 13. So on bottom, we get 17 times 13. I'm just going to use my calculator real quick. You can hear me unlocking it. 17 times 13, okay, 221. Fantastic. 221. Okay. So now on bottom, the radical goes away. That's the whole point of rationalizing. So the radical goes away, and you just get 13. 2 times 13. Anytime you multiply radical by itself, the radical goes away. You keep the number underneath. All right? Which is 26. Okay, 2 times 13 is 26. And that would be your answer, guys. It's a weird, ugly answer. You're probably like, what the heck just happened? But that's it. Again, I repeat. Tangent of t is TOA. TOA. Tangent of t means opposite over adjacent. The opposite is root 17. The adjacent is 2 root 13. So I put that one on top of the other. It says rationalized form. That's this thing right here, rationalized form, which means you cannot have a radical in the bottom. We have to rationalize that by multiplying by that radical. So you multiply the top and bottom by root 13. Here it is, root 13 on top, root 13 on bottom. Next rule says anytime you multiply a radical by itself, the symbol goes away, you just keep the number underneath. So this is really 2 times, that right there, radical times itself, the symbol goes away, you just keep the number underneath. So it's really 2 times 13, which is 26. So root 221 over 26, 17 times 13 is 221. And that would be your answer. That's what you literally type into that bar right there and then hit submit. Crushing it. All right, what's next? Okay, Y3. Wait, what? Y3 again? This was Y3. Apparently I did Y3 twice. Okay, I don't want to do Y3 twice, so I'm going to go back to IXL. Let me see if I can get into that one real quick. Where is IXL? Oh, there it is right here. I gave you Y4, I thought. I'm pretty sure I did. Let me go back into Y4. Trig ratio. Yeah. Yeah, there we go. And, all right, so now here's a good idea. Now you can see exactly what I do. So I'm just going into the IXL, actual IXL, Y4, and I'm just going to screenshot it. Boom. There's one. Smart score of 0. Fantastic. I'm going to jump a level. Jump to the next level. Smart score of 19. Screenshot that one. Boom. Jump another level. What do we got here? 49. Ooh, fancy. Here we go. Screenshot that. Jump another level. 55. Ooh, getting harder. And I'll do another one, 72. Okay, wow. A lot of levels in these. Good luck on these guys. Let's see. Above an 80? No, still not above an 80. All right, we'll do another one. See if we can get above an 80. Ah, above an 80 here. All right. Cool. All right, so I got all those screenshotted. Done. Oh, shoot. Crap. Get out of there. Oh, no. Oh, wait. I can... What? I can write on this? Oh, sweet. Oh, what do we got here? Oh, well, let me go back to the... save the photos. Let me go back to my photos here and pull all those up again. Ugh. Where'd they go? Oh, there they are. What's this one? No, I want Y4. There it is. Y4. Okay, so we want this one, 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 this one. Bring those to the Algebra 2 folder. Save the files. Make that for the Algebra 2. Boom. Save. Beautiful. Okay. Sorry about that. Let's go back into Algebra 2. Crush these things. All right, Y3. Nope. Y4. Beautiful. All right, so these are same exact things, actually. SOHCAHTOA, but it's flipped. Okay, so you see this, like, it's the Y4. It's talking about cosecant, secant, and cotangent. Okay, so if I had the sine function and I flipped that over, if I flipped the sine function over, I would get the cosecant function. If I had the cosine function and I flipped that over, all right, I would have the secant function. And if I had the tangent function and I flipped that over, I would have the cotangent function. All right, that's just flipped, right? So again, one more time, let me erase all that stuff off the screen here. Get off, get off, get off, get off, get off, get off. So we know that the sine function is opposite over hypotenuse, right? So the cosecant function is equal to hypotenuse over opposite. Okay? The secant function, that's the flip of cosine. All right, so let's go back. So SOHCAHTOA. So secant is the flip of cosine, so it would just be h over a. And then last but not least, the tangent function, or the cotangent function, I should say, is equal to the flip of the tangent. It's just, again, inverses. They're flips of each other. Oops, didn't mean to write that line over there. So instead of opposite over adjacent, it's going to be adjacent over opposite. All right. Very good. And then, again, that's it. That's all there really is to it. So find the cotangent of B. So if this is B right here, the cotangent is A over H. So here's the A right here. That's A. And then that would be H. Again, it's always across from the 90. So 12 over 37. And that's it. Not much else to say there. Okay, fantastic. Next, score 19. Cotangent of F. Again, it's the flip of tangent. So if, SOHCAHTOA is equal to over A, then the cotangent of F is equal to A over O. A over O. So here's F right here. And the adjacent is this one. The opposite is this one. So 39 over 80. Yeah, it's already reduced. 39 can be divided by 3 and 13. I don't think 80 can be divided by 3 and 13. But again, I'm just going to double check that. 80 divided by 3. Does it work? No, it definitely doesn't divide by 13 then. Yeah, so that would be your answer there. Submit. Done. All right. Smart score of 49. Getting up there. Cosecant is the flip of sine. Cosecant is the flip of sine. So SOHCAHTOA, so that means the cosecant would be equal to H over O. H over O. Oh, sorry, H over A. So, oh no, what am I saying? Not H over O. Not H over A, H over O. The flip of sine. So we're looking for E. Here's E right here. The hypotenuse is always across from the 90, so that's going to be H, and the opposite is going to be 36. So we got 45 over 36. And that one can be reduced. I think it can be reduced by 3. Okay, so if I divide each of those by 3, I would get 15 over 12. Wow, I can reduce it again. Jeez Louise. I can divide it again by 3. So I could have divided by 9. Divide by 3 again, I get 5 over 4. So I could have divided by 9 at first. But there we go, 5 over 4 would be my answer there. All right, moving right along. What do we got here? Smart score 49, smart score 55. So, again, you saw me jump in level, difficulty level, so we're just going to go by little bit here. Cosecant of T. Again, cosecant is the flip of sine. So I'm not going to write out the SOHCAHTOA again, but cosecant of t would be equal to the hypotenuse over opposite. Here's t right here. All right, so hypotenuse is right here. Oh my gosh, I don't know what it is. Oh, what do I do? Oh, and that's the opposite. It's O. All right, so in this case, I don't know what h is. I don't know what the opposite is, or hypotenuse is, but I do know what the opposite is. It's 45. How do we figure out what the other side is? Oh yeah, Pythagorean theorem like we did in section Y1. 28 squared plus 45 squared is equal to h squared. So again, I'm going to use my calculator. I'm going sideways because I want the... oh, sweet, I got a tweet. Awesome. The good calculator. So I'm going to do square root of 28 squared plus 45 squared. And, oh, nice. Works out really well. 53. Frick yeah. 53 is my answer. So h equals 53. 53 over 45. And can that be reduced? Can I divide it by anything? No, I cannot divide that by anything. Okay. Lovely. So that would be your answer there. 53 over 45. Put it in that little box. Hit submit. Walk away happy. What do we got here? Secant is the flip of cosine. Oh shoot, forgot to hit the pen mark. Okay. So toa. So that means the secant of q would be h over a. All right, so here's q right here. Hypotenuse is 74. The adjacent is right there. I don't know what the adjacent is. Oh, what do I do? Oh, yeah, Pythagorean theorem. So we got a squared plus 70 squared is equal to 74 squared. So I'm going to do a is equal to the square root of that whole mumbo jumbo. I got to subtract. So again, I'm going to do that on my calculator. Flip my calculator sideways so I can do it all at once. Save myself some time. Square root 74 squared. Bam. Minus 70 squared. Bam. Equals 24. Okay. Lovely. So a is 24. All right, so there you go. 74 over 24. Now, obviously, that one can be reduced a little bit. Let's see what my GCF here is. 74 divided by 2. I guess it's just 2. Sure. 37. So it's equal to 37. I'll change my color. 37 over 12. 37 over 12. Boom. Hit submit. Anyway. All right. Am I done yet? Smart score of 72 and 75. Oh, goodness gracious. Cotangent. Opposite over adjacent's tangent. So cotangent is adjacent over opposite of S. Oh, man. I need to get on the opposite. Here's S right here. So the cotangent is equal to adjacent over opposite. So root 21 over opposite. I don't know. Again, Pythagorean theorem. Here we go. Root 21 squared plus opposite squared is equal to 2 root 7 squared. Root 21 squared is just 21. That's kind of nice. Plus O squared is equal to 4 times 7. 28. 28. 4 times 7. So 2 squared is 4. Root 7 squared is 7. 4 times 7 is 28. Subtract 21. You get O squared is equal to 7. Square root that. O equals root 7. Root 7. There we go. So your final answer. 21 divided by 7 is 3. There you go. So root 3. Da-da-da. Root 3 would be your answer. Root 3. Done. Am I done? There's one more. All right, finally, last one. Smart score of 81. All right, here we go. Secant is the opposite of cosine, so hypotenuse over adjacent. Look at that, I'm not even going to write anything out. Hypotenuse of this triangle here is root 73. The adjacent is root 42. Oh boy, can I reduce that at all? 73, let's see, 42 divided by that. So 21 times 2. Okay, so 7, 3, and 2. So I'm just going to say 73 divided by 7. No. 73 divided by 2. No. 73 divided by 3. There it is. No. Okay. All right, so I just have to rationalize this bad boy. So to rationalize, you multiply by the actual radical, root 42. Root 42, like that. And then you would just multiply those two numbers. So 73 times 42. 42, 3,066. Goodness gracious, 3,066. And then it's all over 42 because... why? Because when you multiply a radical by itself, the radicals go away. You just keep the number underneath. And does that simplify? Let's see. 3,066 is equal to 1533 divided by 3, 511. Okay. No, it doesn't reduce. Wow, look at that. I'm liking it. Root 3066 divided by 42. That is simplified, rationalized form. Ugh, that's a gross number. Well, hey, that's the beauty of being a smart score of 81. Great job, guys. All right, that was not bad. All right, there's all 3 sections right there done for you. And I'm not even sure how long, but I'm going to stop this recording now. Have a great day, everybody. Bye-bye.